Hello YouTube! This is the first video in my series on how to cast a ring with a prong setting like this using Delft clay. In this first video I'm going to be talking about how to make a graphite model, which is kind of optional. Making the model yourself with graphite isn't the most common way to go about this. If you're going to be doing it another way, like 3D printing, you can skip this if you want, though I will also be talking about some general design tips which would still be relevant for 3D printing. I'm not an expert on this. There'll probably be things in here that would be better if they're done another way. The reason why I made this video is that, as far as I can tell, there aren't any other videos on how to cast a prong setting in Delft clay, and I wanted to provide additional resources for the home jewelry and casting community. So if there's something on here that you think can be done better, please give your suggestions down in the comments. For those that don't know, Delft clay is a low-cost technique. I think all the equipment that I use to make this ring cost under $400, which, I mean, yeah, it's money, but not compared to setting up a home lost wax casting system. This technique is a little bit time-consuming. I suggest that you use it if you only plan on making these rings a few times. If you plan on doing things long-term over decades, then you'll probably want to learn other more common techniques. But if you're the kind of person who wants to try things out and make some new things just for a few tries, then this is a realistic way of making something that looks relatively professional using low-cost equipment. So on to the video. The job right now is to turn this into a ring blank. So first what I'm going to do is I'm going to mark out some rough borders for where we want things to be, and it will soon become apparent what I'm marking out. So one decision you're going to have to make is how big you want it to be. I'm actually aiming for size 6.5, partly because it's, I think, the most common size, and partly because it's my wife's size, and so I have some parts that fit that. But you may notice that this is a size 7. The reason why is that you've got to account for shrinkage. Normally when I cast a ring this size, across the diameter of it, I lose about 0.7 millimeters in diameter due to shrinkage. So you want to make your model a little bit bigger than your final ring. I think the difference between a 6.5 and a 7 is, I don't know, it's like 0.5 or anyway. It'll still leave enough so that I can take off some of the inside of the ring to polish and get rid of defects in the surface. Okay, and that is what we are going to cut out. So I went through and marked up the dimensions that I'm going to want to cut this thing out for. I set this for 3.5 millimeters wide and gave myself about 8 millimeters of room for what will eventually turn out to be the setting. Of course, both these are wildly more than I'm actually going to need for the ring, but graphite is reasonably easy to sand down or carve down, so it's good to leave yourself with a little bit of extra room. The inside diameter, 6.8 millimeters. Final is going to be, I think, 7.5, which is also just a little bit of room. Then we're going to cut it out and start shaping it down to the final shape. I left a little bit of extra room beyond my line because sometimes the saw blade doesn't go straight in, and I didn't want to have to restart over a millimeter or so of graphite. So now I'm going around and sanding it down the rest of the way to that line. There's no real specific spot at which the model is too thin for metal to flow through. If you get it reasonably hot, the silver is going to flow for a short distance through a hole that's less than a millimeter wide. The question is, how far will it flow through the entire length of the ring? And that's more a point of increasing difficulty rather than a point where suddenly it stops working at a certain diameter. But roughly speaking, cross-sectional area of somewhere between 6 and 8 square millimeters is the point at which it starts to become difficult. Obviously, this is absolutely nowhere near that. I think this is something like 10 millimeters wide right now. Then the last bit of rough shaping that we're going to do is going to be to take this and make it round, hopefully without digging into that corner there too much. Probably a much faster way of doing this, but when I'm not recording clips for you guys, I am listening to my audiobook, so speed is not necessarily my goal here. So there's the very rough outline. Okay, so notice the direction in which I'm using this file. There's a very specific reason for that. What I'm doing right now, I have made a rough sketch of the rose branch and thorns and this little side branch coming off here. And I'm using this file to cut away the excess. But I'm always going to have the file, or at least the vast majority of the time, I'm going to have the file oriented in this direction. And the reason for that is that when we take this model out of the Delft clay, imagine that this file as it is now is the surface of the Delft clay. We're going to be pulling it out like that. So any feature which is oriented in this direction is going to slide out just fine. Any feature that's oriented in this direction is going to break as the model gets pulled out. And you have to keep that in mind when you're designing this. I'm breaking one of my own rules here on purpose. We talked about how all the lines here need to be able to be removed from Delft clay without breaking the Delft clay. So why am I putting this big huge bump here? And the answer is that is something that I'm making at the part line. So the two halves of the mold are going to come together at the point of this thorn, and because they're there where those two halves come together, this is not going to break anything when I take it out. Obviously I'll have to take out all of this. But you have to think ahead for all of the different design features of your model to make sure that when you pull it out, none of them are going to break the Delft clay. Coming to the end of this particular phase, and you may notice that at this point there's a whole lot of right angles on this design, which seems kind of odd for something that's ultimately intended to have an organic shape. But that's entirely intentional, and it tells you about the basic idea of how to make a Delft clay model. Keep in mind, this is not what we're making. This is a tool that we're using to make a shape in Delft clay. So when you're making your design, You have to make a design that's going to work out. Of course, as it is now, this would be at the very least a very odd looking ring. So the next step is going to be to get each of these shapes as close as we can to what it's going to look like in the final ring. Now I'm engaged in taking that rough shape with all those straight lines and starting to give it a more organic look by rounding off all these edges. On this part, it's still going to have that same look with everything intersecting at right angles, but like I said, that's because it has to come out of the sand. Now it's time to start working on the prongs. So what I did here was I cut out a pentagon of paper, and at each of the points of the pentagon we're going to have a prong. And of course, between each of those points I need to cut out a space. This is a pentagon because the prongs are going to be the sepals of the rose, the green things that would normally go up outside the bud to protect it before it opens. And on a rose there happen to be 5 of them. I don't want this to be perfectly aligned up or down or to either side, so that's why it's turned a little bit. Then, after making these marks, I use my handy-dandy calipers to measure each of these lines and make sure that they're the same distance apart, and to make sure that the block that I'm cutting the prongs out of is perfectly round. We're reasonably close. Now, what we're going to do, mostly off camera because it's a pain to do focused, I'm going to find out what the exact center of this is and then start drilling out the center. I'm going to widen this hole with a setting burr. Makes relatively quick progress through this graphite. I'm not going all the way through. I'm not going very close to all the way through. And the reason why is that you never want a hole that goes through your model. You're not going to be able to cast that. So imagine that this is the model here and it's got a gentle groove in it, and then imagine this is the Delft clay going down into that. Delft clay goes in, you pack it down, and then you take the model out. That shape is going to release just fine. Now let's imagine that you've got a sharper angled groove in your model. Put the Delft clay down into that, pack it, and then when you try to take that out, it's going to break right here. Because Delft clay is ultimately just sand that's sticky with oil. So you can't have a really sharp angled hole or groove, certainly not a deep one, without it breaking. So what I'm doing here is I'm just cutting out to the depth of the prongs, and then I'm going to cut out the prongs themselves. But I'm not going all the way through to the inside of the band here, because if I did, then when I try to pull this out, I'm going to be left with this core of Delft clay here in the center. And no matter, it doesn't really matter how much parting powder you put on that, it's still not going to work. Okay, that's all the work that I plan on doing on the model. We're going to move on to casting it and then finish the rest of the work in silver. One thing I should probably point out is that I don't think I am aggressive enough in making these models look like the final product. I get worried that the metal's not going to flow all the way through and the models are all kind of big and clunky. I do think that making something that's about 3 millimeters wide where the metal first comes in is a good idea, but as it gets closer to the other side, you can probably start tapering down more towards 2 millimeters, and in the prongs themselves, 1 millimeter thick will usually cast just fine. It's not really a single point where things stop working. It's more a point of increasing difficulty where you have to get the metal heated up to a higher temperature, and it requires a higher column of metal within the sprue to get things forced through. But depending on how adventurous you want to be, you certainly can get more finely crafted models than what I am doing here. So with that said, this brings us to the end of the video on how to make a graphite model. The next video is how to take this graphite model and cast it in silver. Hope to see you there.